Yeah, I want to talk about lifestyle, and I want to start off, no sound. All right, I'm going to go back and start over. Okay. This is a freebie, it's on YouTube. It's well worth 60 seconds.
What will your last 10 years look like? Will you be quick enough for a game of tag with your grandchild? Strong enough to embrace every moment? Will you grow old with vitality? Or get old with disease? It's time to decide. The average Canadian will spend their last 10 years in sickness.
Aren't you glad we're not Canadian? So I want you to imagine there was a diet or a way of eating that could restore beta cells in a damaged pancreas. A way of restoring insulin production. By the way, by eating. We could prescribe to you a diet program that could do that. Well, you don't actually have to imagine it because it's already been done by 2 different laboratories in the world in mice. And they're working, doing similar experiments in human beings. So what they've actually done is they've got something called the fasting mimicking diet. It's a diet that is low in calories in mice for 4 days. They feed them a very low calorie but high nutritious diet. So it mimics fasting when it comes to calories, but it avoids the nutrition deficiency that is commonly associated with fasting. And what's really interesting is, so this was the first paper that was published in 2017 on this. There was another one that was done, I'll show you in a minute. But what they did was in mice, 4 days of this very low calorie, high nutrition diet, and then they let them eat normal food, normal diet for the rest of the month, and then they did it again, 4 days, and eat normal the rest of the month. And after 3 cycles, this is what they found, that the FMD stands for fasting mimicking diet. They restored insulin secretion, even in type 1 diabetic mice. So this is kind of earth-shaking. We're still looking to see where all this is going to go. And here's the paper. The authors said that they discovered it did was this way of eating, this pattern, caused new cells to be formed in the pancreas spontaneously. And said it said it was similar to embryonic development, where the pancreas is developing, in the early embryonic stage. Then here they did it again. This is the same one. This is details about here they've done it in humans, but they haven't. In the mice, they were able to sacrifice the mice, do an autopsy and a biopsy on the pancreas and prove that they were forming new cells. We're not doing that in humans right now. But they did do it 5 days, and you can see the 1,100 kilocalories the first day and then dropping down to 715 in a 5-day cycle. And they saw similar results as far as improvement in blood sugars, etc. So we suspect that the very similar thing is happening in humans. And then this was the second study published in 2018, a year later. This group, they also looked at the microbiome because there's some suspicion that part of this process may have to do with the microorganisms that live in us. Are you aware that if you take a human being and put them in a bag, like a sleeping bag, not a plastic bag, and that there are more non-human cells in the sleeping bag than human cells? That's right. We have many more cells in us and on us than the cells in our body, because those are microorganisms. They're smaller than us, okay? Their cells are smaller. But the point is, there's a lot of non-human DNA in each one of us, and it's been shown that those microorganisms affect not only our physical body, but our thinking, our attitude, and most likely some of our spiritual aspects as well. So, let me say about this. Let me stitch that off. Why I mention that is that when we eat, we're feeding not just our cells. We are feeding the microorganisms that live in and on us. And what we've shown is, that if you feed the different types of diet that I eat will create and support a different type of microorganisms in my gut and on my body. And so one of the big differences is animal food diet versus plant diet. There's a dramatic difference in the microorganisms that are living in and on us depending on our diet. So going ahead with this group, they basically confirmed the same thing that the other group had found. So I want to now show you, I want to help you see how powerful these gene switches are. So I just want to give you a couple of demonstrations. Here's one that was published 14 years ago, that long ago, but let me show you what they did. These researchers, they found a set of switches on particular genes that they could change, and they could turn skin cells, mouse fibroblast skin cells, into functioning heart cells directly. They went directly from a skin cell to a heart cell by changing the switches in the skin cell. And as their research goes on to say, that they were directly reprogrammed, and they functioned like functioning cardiomyocytes. Okay? Another little illustration. This is a picture I took when I was doing federally funded research on diabetes in the Marshall Islands. So if any of you have ever been to the Marshall Islands, this is actually a picture from Majuro across the bay. The Parliament building, or the Nitagella, is, well, I don't know. But anyway, it's right over here. And I was there, thank you for your tax dollars. I was there at your expense, our expense. I pay taxes too. Because in the Marshall Islands, a survey that was done in about 2003 showed that 40% of the people 18 years of age and older are either diabetic or pre-diabetic, and the rate's going up. 80% of the admissions to the hospital are from preventable complications of hyperglycemia. In other words, it's a catastrophe unfolding. So we wanted to see if we could use lifestyle and diet to help turn that around. And we did. The program, this research was turned into a program, and they've been having the Diabetes Wellness Center running now for over 10 years. Here's some of the pictures from that. Some of you might recognize Dr. Wes Youngberg, who's come back to the mainland since the time he helped us, and he's really gotten involved in memory improvement and Alzheimer's disease, working with Dr. Bredesen program. And here's somebody that you might also recognize. By the way, that was where we were testing sugars. This is where we were testing fitness. This was the compounding pharmacy. Okay, spelled with an F. Anyway, this is the kitchen. This is Brenda Davis. Brenda Davis is a lovely lady from Canada. I'm sure she won't spend her last 10 years like the video showed. And she helped us out as the lead nutritionist. So here's a graph from the first group in that research in the Marshall Islands. It was a 10-day intensive program to start off. We kicked it off with 10 days, so 1 through 10. And here's the sugars that we took from finger sticks from the first day throughout the program. So isn't that amazing how, I mean, the R squared, as they call it anyway, this is a very good fit. It's a very linear. In other words, the changes were consistent every day for 10 days. And you can, here's the equation that tells us the total change was about 74 milligrams per deciliter in 10 days, drop in blood sugar. I remember the first time I showed this was in Honolulu at a medical conference right after we had the results. And someone asked me, well, how did you do this? Did you put an insulin pump on these diabetics? And the two people in this group of, I think there was 18, 16, two diabetics we had to take off of blood sugar, off of insulin because their blood sugars were getting too low. And so I said, we were using something more powerful than insulin or the insulin pump. And they were like, what is that? Well, it's diet and lifestyle. We had them doing basically a New Start program, okay? Nutrition, exercise, water, sunshine, temperance, air, rest, and trust in divine power. Ministry Healing, page 127, paragraph 2. So this is what we saw in the very first group. Now I want to show you a third little case history. This is just a simulation of an echocardiogram, okay? This is where we use ultrasound to visualize a working heart. It's very similar to the technology that we use nowadays on every pregnancy, it seems, has to have a pre-birth photograph of the baby from ultrasound. But anyway, you can, with our modern technology, we can visualize tissue and in motion. So this patient who happens to have the same last name because he's my older brother, and I have his permission to share his details. He had a very thorough evaluation as he retired and was going to go on Medicare, and the doctor discovered some abnormality in his EKG. He was on a stress test, and at the high level of exercise, the internist saw something amiss. Sent him to Dr. Spady, a cardiologist. The cardiologist evaluated everything, and this is what he said. Let me blow it up. After reviewing everything, we have recommended he undergo coronary angiography with intervention if indicated. In plain English, they were going to do an angiogram. If they saw a blockage, they were going to put a stent and open up the vessel. Well, he's one of these patients that we doctors love, tongue in cheek. We really do appreciate patients who read and learn about their disease. But sometimes they disagree with our treatment, and so he didn't want to have that. He looked up and he found out, it never occurred to me that a patient would do this, but he found out that 1 in 500 can be fatal, because if that vessel in the heart bursts when they put the stent in it, that's an emergency. You need to be, that's why you have to be within 10 minutes of an OR when you do this process. So he said, I don't want to do that. And he called me up and he told me, and he says, I want to make lifestyle changes. And I said, you have to, this is a serious condition. This could kill you. You have a problem with the blood flow to your heart. And he said, well, I'll become a vegetarian. Like that was, I said, well, yeah, well, beer and pretzels are vegetarian. You won't have any trouble with that. And that wasn't too far off. He doesn't eat that way anymore. But there was a time in his life when I think he survived quite a bit on those kind of things. Anyway, so he did. He became a vegetarian. And his cholesterol dropped like 40 points. It was still over 200 and something. So he wasn't out of the woods. Anyway, so he decided, okay, I'll come to your center. We had an outpatient lifestyle center. And he came to our program, went through it twice. So not just 30 days, but 60 days, all right? And so this was after that. So it's almost 2 years later. You can see 2006, 2008. And here's what Dr. Austin said after those two. He said the echo portion of the test was negative for ischemia. The patient had done well with lifestyle changes, and what was the plan? Continue with lifestyle change, diet and exercise, and aspirin. So I got to talking with Dr. Austin afterwards, And he said, you know, I've never seen that happen. I wonder if that first study was artifact. He was more ready to believe that it really wasn't heart disease than to believe that it had reversed. And I can understand because it is rare, but it is extremely possible. You see, you have to first understand something can be done, usually, before you're willing to undertake to do it. So anyway, now I want to show you some examples, what I would say are transformative thoughts. So this is a study from New England Journal of Medicine, 2009. It was a study done by cardiothoracic surgeons. Those are the ones that either do heart transplants or they do bypass, where they take, you know, a vein out of your leg and bypass all the clogged arteries on your heart. Well, what they had noticed was that it had seemed that the failure rate, remember Bill Clinton had bypasses in his first term, and then in his second term he had actually another heart attack and he had stents put in it. So he had to stent the bypasses. And he actually became a vegetarian. I think you're maybe aware of that. And he was being interviewed by Wolf Blitzer, I remember, and he said he had lost 26 pounds. That wasn't why he went on this diet, but he had come to realize that his bypasses clogged up, so he was in danger of having a fatal heart attack. Well, anyway, they had noticed that the failure rate, 12 to 18 month failure rate, was different depending on how they took the vein out of the leg. So if they did an open excision and made this long, when I was a student, I was in watching some of those, and they cut with a scalpel all the way up, skip a little bit here and cut on up your thigh and take this nice long saphenous vein out. And then they cut it to the right length to stitch into, to bypass arteries in your heart. Well, there was another way that was becoming quite popular to get the vein, and it's called endoscopic method. That's where they make a few holes and stick an instrument in there and harvest it. Well, when they did this study, they found that the failure rate was 38% if they had an open excision, and 47% if they used the endoscopic methods. And it kind of makes sense to me, because in the endoscopic method, while it doesn't make as much of a scar, it's a little bit rougher on the vein, okay? It gets mangled a little bit more. And the combined rate was 43%. So why in the world is a lifestyle medicine doctor looking at articles on bypass failure rate? Well, the reason is that this graph, 43% fail in 12 to 18 months without lifestyle change. But with lifestyle change, how long do you think it would take? Well, let me just show you. If you haven't seen this, this is a picture of the change that happened in Dr. Crow's arteries in 32 months. Here's a blow up. So Esselstyn, Caldwell Esselstyn, has this in his book, an example of how many blockages. This artery here is just full of atherosclerosis. That's why you can barely see it. The dye hardly goes through there. It was way too many blockages to put stents in. For sure, you put that many stents, you're going to blow the artery open. So, but after 32 months on a plant-based diet, and by the way, he was allergic to statins. He could not take statin medication. This is what we see. That looks more like a teenager's artery. So, on the one hand, the average failure rate in 12 to 18 months is how much? 43%, the combined rate, okay? And 47 if it's endoscopic. Versus an actual opening of the arteries. So, you know, I think this is something that every patient who's got being considered for bypass surgery should be made aware of. Wouldn't you agree? I mean, if you were being diagnosed and recommended that treatment, wouldn't you like to know about this? I think personally that it's not correct, informed consent without telling people about that. Well, anyway, so now every time I share these kind of of histories or stories, people say to me, but Dr. John, I've just got bad genes. You know, it's on both sides of the family. My brothers and sisters have it, and I've got it too. Do you know that we inherit something besides genes? Cookbooks. Yeah, we inherit cookbooks. We also inherit lifestyle habits, okay? And that's a good thing, by the way. We can pass very good habits on to children, or we can pass less than good habits. Anyway, so yeah, we've got bad genes, but in reality, turns out that's not the main cause of our chronic diseases, which the statistics published in the journals of medicine say that 80% or more of the visits that people pay to doctors in America are for preventable lifestyle conditions. So, let's take a look. I want to show you this. This was a Time magazine, January of 2010, so that's 14 years ago or more. And what it was talking about was the new science of epigenetics, new in 2010, reveals the choices we make can change our genes and those of our kids too. I mean, I would have been taken to the loony farm 2 decades ago for saying that, and they published it on the front page of Time magazine. Because, I mean, this alone would be amazing to change your genes, but your kids? How can you change your kids' genes? Well, stay tuned, because this is very interesting science, and you really already know this. I'm just going to remind you of things that you know and show you how it comes to these conclusions. All right, so let's review a little history. This is an actual picture of Dr. Watson and Dr. Crick receiving the Nobel Prize for their work that demonstrated that this deoxyribonucleic acid, or DNA, molecule contains the information passed from one generation to the other, called genes. Okay, by the way, you know this is a double helix, right? Sort of twisted around each other. Did you know that these two strands are not literally touching? They are held in place by hydrogen bond type forces. This is called a base pair. All right, you know there's A, C, G, and T. And so an A is matched with a T and a C is matched with a G. And so anyway, these are base pairs. The reason I mention that is when we're talking about how much DNA it is, that's what we say is how many base pairs. So it's basically a way of measuring its length. Okay, by the way, and the amount of DNA in a cell, in a human being, is about 2 meters. So we have about 6 feet, 6.5 feet of this thing, if you could stretch it all out. It fits into a cell that's small enough it's barely able to be seen by the naked eye. So another little fact that you're maybe aware of, this is Dr. Francis Collins, who not too long ago retired from being director of the National Institutes of Health. But he was, in 2010, he was in charge of the Human Genome Project. They sequenced the first complete set of chromosomes from a human being. And they found about 3 billion base pairs. That's 3 billion base pairs in a cell, because every cell has a complete set of chromosomes, right? Millions of variations. That's where, by the way, that's how this DNA testing works. There's so many variations in our DNA from person to person that it's a better identifier than your fingerprints. More unique than your fingerprints. By the way, some of these variations cause disease. This is the sickle cell. You can see it has a sort of a sickled shape. That's where they got the name. This is a normal red blood cell. That's the result of just one difference, one mutation in the DNA, okay? So it can make a big difference or make little or no difference. All right, another lesson from biology. While you think about these little creatures here, these are actually mammals. They almost look like some kind of a nut or a chinky pin or something. But anyway, these are triplets. Where does all mammals, including human beings, come from? We come from an egg and a sperm. An egg from mom, okay, an ova, and from our father, biological father. And the only fate that both of those cells have is either they have to join together to make a zygote, which has the complete set of chromosomes, right? Each one of the egg and the sperm both have only one set of chromosomes. You need two, right? You have to have pairs. So if they don't combine within a few hours or days, they'll die. Well, obviously these joined, made a zygote. That zygote became two cells. Somewhere around the 30 to 64 cell range, we call it a morula. Or there's a morula stage and a blastula stage. And all of that in human beings happens as this mass of reproducing cells is going down the fallopian tube until it reaches the uterus, where, if everything works right, and since you're here, I know it did, and you found a home on your mother's wall of the uterus. And there, you created a placenta and started taking nutrition from mom. And those cells kept growing until, in our case, humans, 9 months later, again, if everything works right, you're born. And every cell in your body came from that very first zygote, right? It's the only place it can come from. Okay, so here's my question. If every cell has a copy of the same DNA, how does it produce such different tissues? You know, some of it makes an ear. You know, some of it makes, what, a toe, a liver, a brain. Did you know that you have all the genes for a liver in your ear? Aren't you glad they're turned off? In fact, you have all the genes for a left ear in your right ear, because they all have the same DNA, right? That's why I can say that. I could make up anything out. You have all the genes for an eye in your ear. It's true, because every cell has the same set of chromosomes. Don't you think that's a reasonable question? How does it produce such different tissues? Well, the answer is something called switches. Dr. Whitelaw, let me quote her, she's an expert. She says we do not inherit just DNA. We inherit chromosomes. And chromosomes are only about half DNA. And then the other half is made up of proteins and molecules that actually we used to call chaperone proteins. You know, I said I was a new doctor, so what I mean is I went to school later, and so I took biochemistry and molecular biology for my undergraduate. And and that wasn't that long ago. What was that? 25 or 7 years ago? So okay, that is a while. But anyway, I was taught that all of that other stuff were chaperone proteins, and they even called the DNA that was not a genetic, didn't have a gene, we called it junk DNA. That's what I was taught to call it. I'll bet you even Dr. Hess back there was probably taught the same thing. So the point is, we now know that was a gross misunderstanding. It turns out that much of the DNA that's not a gene is a switch. It's involved in the switching process for the part that is genes. In fact, what the experts have told us that know about this in detail is that the switches on our genes are probably orders of magnitude more complex than the genes themselves. It's really, some genes appear to have thousands of switches. Now, if you know anything about, this is a very simple illustration, but if you know, many light fixtures or fans or whatever in your house have one switch, right? One place to turn it on and off. But some of them, like on the stairs, they'll have one at the bottom and one at the top, right? Two-way, right? Well, you probably are aware that there are some places where there's 4 or 5 switches for the same thing. Well, in our genes, there's literally hundreds and thousands, perhaps as many as tens of thousands of switches for a specific gene. All right, let me just show you something. Now, you could take me at my word, and you might do that, but I like you to understand, instead of depending on what I'm telling you, that you can see from science. So what I want to do is show you a couple of things about this. So monozygotic twins are commonly called identical twins, right? Because they come from the same zygote. That's monozygote, right? One zygote produces 2 people. Theoretically could produce 3 or 4. And what happens is, during that early stage I was telling you about, the blastula or the morula stage, if some kind of a physical trauma or something causes that mass of cells to split into 2 parts, and it doesn't have to be in half. It could be 1/10 and 9/10. Both pieces will become a person. And so that's how we get monozygotic twins. Well, now here's what they did. They were trying to show how switches change during our lifetime. And so they took twins, 2 sets of twins. These are represent 2 people from the same zygote, A and B, and they're at 3 years of age. And what they did was they looked at, this is a polymerase gel electrophoresis is the technical term, but it's a way to separate the proteins in the blood and see where they are. And you can see that the bands are very similar. There's minor differences here at 3 years of age. But look what happens when they look at twins, not necessarily the same people. Okay, these are different sets of twins, but they're 50-year-old, and look how dramatically different the gene expression is. So that's just a real simple way to show you that even though you have the exact same genes, your gene expression can be very different. So, and this, another thing I really like about this little study, why I cite it, this was from the Proceeding of the National Academy of Science almost 20 years ago that we were aware of this. But what it shows you clearly is that the switches have more impact in many ways than the genes do. So that's how powerful these are. So, we've talked about this. Oh, I didn't mention that second point there. So far, the most powerful influence upon gene switches appears to be our diet. Now, there may be some things that change the switches but in a similar way, but diet seems to have a more global effect. Our food, our diet, and maybe it's because of the microorganisms that it promotes in our body, but somehow it affects many of these gene switches. Many other things like exercise also affects our gene switches, but not in as dramatic a way and as wide a scope. So I want to talk to you just a second about how we started off. So when you were born, you had genes, obviously, and they were either on or off or partly on, right? Like there's something called a rheostat, like lights that you can dim. Okay, so it not only has an off switch and an on position, but it has in the middle. Well, our genes have a similar kinds of switches. Well, the way that, since these things are from generation to generation, the bottom line is that when I was born, you were born, the switches on our genes were not set by our lifestyle. We hadn't actually had one yet. They were set by the influences on our parents, right? While you were in the womb. But did you know that in the case of the female gonads, the ovaries, the ova, the eggs, are formed in the ovaries in the first few weeks or months of the pregnancy. So the egg that you came from was formed in your mother's ovary while she was in your grandmother's womb. So it's been interesting that in some of the Norwegian countries where they have amazingly extensive records, they've been able to actually show that the environmental influences on the grandparents at puberty correlate better with some chronic diseases than the parents' lifestyle. So anyway, it's just to help us see how connected we are across the generations and how it also affects the switches on the genes that we're born with. All right, now I'm going to show you about four studies, and we'll close it off and have some Q&A. First, I want to talk to you about the agouti mouse, the one with the dollar signs. The reason it's so valuable, it's worth hundreds of thousands of dollars, is that they've spent a lot of time engineering into this mouse, these mice, DNA for human disease. They get obese, they get high blood pressure, they get diabetes, they get atherosclerosis, all these diseases that we're trying to find answers to so they can study them in mice. Okay? The other mouse is just the kind of a mouse that, in fact, there's one in the house where I'm staying, and it's leaving its little droppings here and there every night. And if I catch it, I will throw it away. But not this one. Okay, well, so the researchers, I should go back and show you this here again in a second. Stay with this. I've got to tell you more of the story before I show you that next slide. Researchers who are working on this business of imprinting, which is where it seems that during the embryonic development, there were switch settings taking place that affected the offspring. And so they thought of using these agouti mice to see. So what they did was they did an experiment where they had agouti mice, fed them a certain kind of a diet that was designed to turn those genes that had been engineered into her, to turn them off. And when the baby was born, history was made. This is an actual picture of the offspring from the mother and her baby. And you know, if this was a human situation, we would have a paternity suit. I mean, this is not my kid. But they did that. They did the gene studies and showed that the genes in this mouse are in this mouse. But they were turned off so completely that you can't even see it. In fact, the color of the coat was engineered as well, so it'd be easy to tell these mice if they have the genes. And so the researchers said that the effects, I didn't include that slide, but they have they said the effects of this methylating diet that changed the gene switches was evident in the offspring for 3 to 4 generations. Isn't that interesting? Always reminds me of Exodus 20, 3 to 4 generations. All right, now I want to show you a different study. That was in mice that had genes engineered into them, and they turned them off. Now they're doing a study in rats that are just wild type rats, no special genetic engineering, and they're going to see if they can turn genes on with a high-fat diet. This was published in the Journal of Neuroscience in 2008. And let me show you, I love this stuff. Of course, I was, like I say, I took that kind of science when I was an undergraduate. I wish, if I hadn't become a physician, I think I might have done some of this kind of work. But what they showed was when the mother's fed a high-fat diet, in utero, the developing fetus has on chromosome 3, there's a gene that's turned more on, and it causes the production of increased number of neurons. And these neurons that are produced, by the way, let me just stop a second. What did I just say? I said that the way the mother ate during pregnancy changed the anatomy of the baby's brain. Has more neurons, and the neurons in this case are particular neurons that migrate to and form the hypothalamus. And what we call phenotypic characteristics, let me blow that up so you can see it. This is the phenotypic characteristics from weaning to adolescence. Higher blood lipids, more fats in the blood, a higher food intake. Given an opportunity to eat, it will eat more than a baby born to her when she's on normal diet, normal feed. Prefers fat, which is what we fed the mother. Early puberty onset, higher body weight. In fact, what really first brought this study to my attention was I was reading an article from the health reporter in the Wall Street Journal. And they were commenting on this amazing study, and they had asked the acting director of the American Heart Association to comment on this. I guess because they were meeting at about that time, November 2008. Anyway, what the lady said was, this study shows there's much more to America's obesity epidemic than we have ever realized. Why would she say that? Because, do you see the positive feedback loop? Higher fat, prefers fat, eats more fat. This is the same kind of a loop, by the way, that produces a delivery. The delivery of a baby. Once it gets to that point where there's no stopping it, this baby is going to be born. And so I do believe this can be interrupted. They've shown that if you restrict the fat intake, that this effect goes away in future generations. But if you allow it to go how it wants, it becomes a positive feedback loop. All right, another study. I don't know if we're going to go up or down this time, but we're going to talk about some men with prostate cancer, the most common cancer in men in the world now, as I understand it, not just in the first world. So this was just 30 men with low-risk prostate cancer. We call it indolent, meaning it's not, vigorous. Most men that have this probably would die without knowing they had it or having any particular symptoms. They didn't get surgery or radiation. Instead, they had a comprehensive lifestyle change program. And you can tell from the author of this study, Dean Ornish, they actually basically went on the Ornish program, which was originally shown to help reverse heart disease. But in subsequent studies, they found it had a lot of other benefits as well. So they're using it here on cancer. What these men did was they let the researchers take a biopsy of their mass, their prostate cancer, and from that tissue, they could isolate messenger RNA. Messenger RNA, of course, nowadays, after COVID, we've all heard of that. Messenger RNA is produced when a gene is turned on. It's transcribed from DNA into messenger RNA, and then it goes out into the cytoplasm where ribosomes use it to produce proteins. So they basically had a way to see which genes were active at baseline and 3 months. Now this thing is called a heat map. It's a simple way to portray all that data. So there's 30 columns here, if you counted them, at baseline, and 30 for one for each man after 90 days. There's a row for every messenger RNA that they identified. And then the color is light if there's not much, or dark if there's a lot of that messenger RNA. So it's why it's called a heat map. You can look at it, and most people can say, well, this site over here is hotter. It's more color, this one. But some of them went from light to dark, and many of them went from dark to light. So when they counted it all up, it was over 450 genes that were turned down or off, and only about 50 that were turned up. They didn't know all of these genes. Some of them they did not know what they did, but some they did, and what they said in the article was that there were many genes in this group that turned down that were known to have to do with cancer growth, causing cancer. And some in this group anyway, were recognized as cancer fighting. So it appeared that the direction that the switch was turned was favorable, whether it turned it up or turned it down. It seemed to have the wisdom, or whatever you want to call it, to be able to move the expression in a favorable way. By the way, what was it these guys had that we were studying? Prostate cancer. Yeah, it was it's not a trick question, but but wait a minute. It looks like it was a weight loss. They lost, these are kilograms, so somewhere around 5 or 6 pounds. But no, it was actually blood pressure clinic. Their blood pressure dropped over 9 points. No, it was a cholesterol intervention. Cholesterol. So my point is, trying to be cute here, that if you treat any condition with lifestyle changes, you will see other things improve as well. The side effects are not harmful. They tend to be beneficial. You could have some ill effects if you had a food allergy you didn't know about and you started eating something and you had but that would be a short-term problem. All right, well, let me contrast that now with a couple of other studies and then we'll end. So this was in Circulation, the American Heart Association journal, 20 years ago, and they did a randomized study. which is the strongest design we have, and they were comparing stenting to exercise for stable coronary artery disease. What that means is these were people that had pain or angina symptoms when they were active, but if they rested, it went into abeyance. And so they compared stenting with exercise, a randomized trial, 1 year, and 51 patients were in the exercise group. So how vigorous was their exercise? 20 minutes or more a day, 70% of symptom-free heart rate. In other words, for the typical person, probably they were only exercising their heart rate up to about 110 or 120. So and they kept it below the rate that would cause any symptoms. So that's pretty mild. And they had 60 minutes a week of aerobic exercise to keep the group going. The 50 assigned to the stent, 50 of these people randomly assigned to get a stent. Now, don't answer me out loud, but I do want you to actually think, if your relative or your husband, wife, mother was in this study, which group would you have been hoping she would get into or he would get into? Because most of us would say, well, I hope they get treatment. Well, of course, I'm showing this to you because the results are so remarkable. So this is called a survival curve. Everybody started off 101 people, right? 51 and 50. Anyway, all 101 were surviving with no events. But as the different people started having symptoms or heart attack or whatever it might be, the line comes down. So the exercise group, 88% were totally event-free at 1 year. The ones that got the stent, 70% were event-free. That's about a difference of almost 26%, relative difference. So again, I think personally that moral medicine would inform people of this information, because probably in many cases the best thing might be to get a stent and exercise, but certainly exercise and now, did you know, since this study was done, it's the American College of Cardiology has published their recommendations, and they do not recommend a stent more than 24 hours after the event. If you have a heart attack or you have some kind of pain, the ill effects outweigh the benefits, is what the experts have said after 24 hours. I don't want to go here, but I can't help telling you this. So I've looked at the studies that they did, and they published in the Journal of American Medical Association, they published a study showing that after that recommendation came out, they had a number of studies that were going on heart disease and stenting, and the researchers went back and looked to see if after the American College of Cardiology changed its recommendations, was there any difference in the rate of doing the procedures? What do you think they found? Well, even if you're a hypocrite or a conspiracist, what happened was the rate actually went up. There was two editorials in that same issue trying to explain why would that happen. Anyway, that's another talk. So, here's a quote from Dr. Andrew Feinberg. He's one of the premier leaders in this field, works at Johns Hopkins Center for Epigenetics. So this is a quote from him. Epigenetics is at the epicenter of modern medicine. This is not a peripheral thing. In fact, what I understand now is that the National Institutes of Health, anytime that they fund a study that's looking at the DNA and the genes and trying to correlate how they impact health and disease, they mandate that you also have to measure the epigenetics. That would make sense, wouldn't it? Because if you were to go into a building and you're checking to see if the lighting is sufficient, and you take your meter and you go walking around, wouldn't you think you ought to at least turn the lights on before you do it? So the point is, if the switch is turned off, you're not going to find the correlation that you think you find. Okay, and then this quote here is very interesting from Dr. I've never heard the name pronounced. I believe it's Kepet, but I'm not sure how you say it. Anyway, he says lifestyle has the greatest effect on gene expression of any factor that we've been discovered so far. In fact, there's a whole science of nutrigenomics that's developed because of that. This was the guy that did the landmark study in the agouti mice, Dr. Jerdl. Look what he says. Epigenetics is proving we have some responsibility for the integrity of our genome. Before, meaning before we understood about the switches, genes predetermined outcomes. Remember people saying, well, you can't pick your parents. That's true. But now everything we do, everything we eat or smoke can affect our gene expression and that of future generations. Epigenetics introduces the concept of free will into our idea and understanding of genetics. Now, many of us, Christians especially, or believers in a creator, knew that it couldn't be that we are mere robots following the instructions of our DNA. I mean, that's just not the way God created us. But we didn't understand how until we learned about the switches. Well, now, turns out that if you want to change your switches, you can do it. Did you already catch it? How can you change your switches, the ones that you can change? We don't know if you can change every switch or not. Probably not every switch, but right now, my understanding is if someone asks me, do you think that I can change a switch that's going to affect whether I'm bald or not, I'm going to say, I don't know, but I would be afraid to say no because we keep on finding new things that we can change. How do we change it? Diet would be the strongest, but basic lifestyle, right? How I choose to live my lifestyle. And all it's doing is affirming what we heard for a long time, right? The way you live determines the way you die. And so, all right. So here, you can tell I like graphics. So this is, if health is the physical characteristic we want, right? Here's the drivers. The DNA sequence, which we're born with, we can't change that, only about 8%. Maybe less than 8% of the difference in the health between people. Medical care, maybe 10%. Actually, nowadays, we know that's going down, unfortunately, because, I wouldn't want to badmouth my own profession, but the fact is, hospitals are a dangerous place to be. And we're making too many mistakes, and we're doing things the wrong way. We need to improve. But anyway, the environment. Here they're talking about like living on the shore where there's a tsunami, or they're living close to Chernobyl. That's what we mean here. Weather environments or events have an impact on health. But fully 75% or more is from our lifestyle choices. And that's the part that we actually do have control of. I know that there are many people, I work with a lot of people in my lifestyle practice that feel like they have no power. I can't do anything about it. I've tried to lose weight my whole life. Well, we know that it can be done. We also know that for some people it's much harder than others. Okay? I used to smoke, do a few other things that we'll leave unnamed, and I quit multiple times before it stuck. I have good company. Mark Twain said quitting smoking is easy. He did it thousands of times. And but I don't think he ever really wanted to stop for good. But what motivated me? I remember vividly that I woke up one morning after, I was not a Christian, I woke up one morning after we had had a party, and my daughter, who was not even 1 year old yet, and so she couldn't walk, but she could crawl up on the furniture. She had crawled up on the end table and taken one of my cigarette butts that I'd put out in the ashtray, and she was trying to, it looked like she was trying to eat it, but anyway, she was probably imitating Dad, right? I thought, oh my goodness, I have to stop this filthy habit. And so and by the way, she's smoking right now, and I told her, I says, I wish I could do for you what you did for me. I believe she's going to quit. Okay, so can you do that? Yeah, it can be hard, but it's doable. And as a Christian, we have a secret motivation. We have secret power. Christ promises to help us make the right choices. And if you do that, it'll change your epigenome. We've shown that with the monozygotic twins, different ways that I've shown you. This happens if you do that. And if you change the epigenome, well, you change the genes that are expressed, right? And if we change that, we could change a skin cell into a heart cell. In other words, we can literally change the makeup of our body. So you have a lot of latitude built in. We're designed with some amazing capability for self-determination. The problem, of course, is motivation. I don't know about you, but I know I fight habits, old habits, long-established habits that I want to change. I have enough information. I'm convinced that is not something I want to continue. And yet, the nature of a habit is what? It happens without us thinking. So I have to, and you have to change a habit, you have to think consciously about the change repeatedly until you get the new habit. And then we have this wonderful promise that if we are faithful to Christ and to His leading, we can come to the point where we will be carrying out His will when following our own impulses. Isn't that encouraging? So, anyway, yeah, I'll end with this. This is a chart. I mean, I took epidemiology as a master's degree when I was at Loma Linda, so I had this biostatistics knowledge. And what I do is anytime I get data like this, we had 23, we call it Start a New Me. It's basically similar to New Start program. And we had 23 of the guests from Grand Rapids, and this is what I found. The simplest way to look at this and make sense of it is these gray areas are drop. The red is the person who had the greatest percent drop, and the yellow is the average overall for the whole group. So this is obviously much greater. But you can see someone went from 373 to 102 triglycerides in 2 weeks. 263 blood sugar to 84. So you can be sure she had to come off of medication in the process. So anyway, it works, it's powerful, and so I think I'm through. Yeah, well, I will mention this. So in 2000, when was this published? New England Journal of Medicine, 2005. There was an article about how America's longevity has been increasing for 200 years. But in the year 2000, it's projected by the experts that the generations will not live as long as their parents. So our children and grandchildren are statistically likely to live a shorter lifespan than we do. That shouldn't be happening, right? And I don't know all the reasons for it, but one thing is for sure, it's because our diet, both in our mouth, our eyes, and our ears, is going in the wrong direction. We're living on the wrong things. And I believe that, I know I feel a personal responsibility to try and help change that. So I work in lifestyle medicine, that's part of it. But I also do my best with my children. My children didn't turn out perfect. I don't know if anyone, on the other hand, neither did Christ's children. Not only did Lucifer go the wrong way, but so did Adam and Eve. So I don't take a guilt trip. I'm not asking you to have one. But think about it. Those of us who understand this are the ones that have the best opportunity to teach it to others. And so let's support teaching these principles to children. Okay, I'm going to stop there. I won't explain that. That's self-explanatory. The Adventist studies, literal, careful studies show that Adventists enjoy about a 10-year longer lifespan. Did you know that based on Adventist Health Study 2, the percent of vegetarian Adventists seems to be dropping. Okay, I'm going to stop. I will take questions about anything that I've shared or something else that's related to this if you want to. Or oh, yes, sir.
Heart rate during exercise. For the most part, I have a tendency to bring mine up to about 120 for a period of time. What is the optimum? Should it be any higher than that?
Well, here's what we do. We say you take 220 and subtract your age. So you take 220, subtract your age from that, and then you take, to be safe, you would take, say, 70 or 80% of that. So your maximum heart rate for your age is given to your age. So 220, let's say a person was 60 years old. So that would be what? 220 minus 60 would be 160, right? And so then I would take, say, 70% perhaps of that, and that's what I would consider to be a safe and effective heart rate for exercise. Yeah. Anything else? Yes, ma'am.
A lot of things that you said to me were very interesting. My husband died of prostate cancer. He battled that for 30 years. But no doctor that he ever went to said it would really be beneficial for you if you went on a plant-based diet. They don't do that. So how they treat that is to either remove it, the tumor, or have radiation. He chose radiation. And so in years to come, he had side effects because of that. So there's things that they could have recommended when he was first diagnosed, but they don't advise that because it takes too long for that to cure it. So they do it their way, medically, surgically, or with the radiation.
Right.
He also had various heart diseases like the stents and open heart surgery and all of those things. So if children are raised in a plant-based diet, I think that's the best way to handle it.
Sure it is.
But to wait until after you've got these serious problems and then try to go to a plant-based diet and say, this is probably going to fix it, it might not because it's too late.
Yes, but I would point out...
When you answer the question, can you just summarize the question for our online audience?
Thank you.
Hear
yes, that's a great idea.
Just summarize the question.
Yeah, so the question is about a spouse that had prostate cancer. He survived with it for about 30 years, but they didn't recommend really lifestyle change. And she was commenting on that, and I thought you were making a point, I don't know if that was your main point, that they sometimes will say, well, that takes too long. The lifestyle change, the person will die before they get well. Well, how long were these men in the study studied? It was 90 days. It's seldom you're going to find a prostate cancer that'll kill a man in 90 days, fortunately. But the other thing I want to say is they are now, medicine is now recognizing the value of lifestyle change, and not every doctor by any means is doing that, but it's an increasing number. And lifestyle interventions act much faster than doctors thought 20 years ago. I can still remember I was a student. In fact, Dr. Hess and I were fellow classmates at Loma Linda Medical School, and he holds his age a lot better than I do. But, it's a joke. But, well, he probably does. But the point is, I remember sitting in at the County Medical Society as a medical student, and they were happy to have us there. And they were talking about something, and I asked the question, well, wouldn't lifestyle have the potential to help that patient? And one of them smiled at me as a fledgling medical student, doesn't really know much yet, well, it takes years for chronic disease to develop, and it'll take years for it to reverse. And I had already seen the Dean Ornish study that showed that you could reverse it in months. So, but I didn't, I thought it was the best part of wisdom not to say that. But at any rate, I hear you, but I'll tell you something else that's interesting as a lifestyle medicine practitioner. It's hard to get young people interested in doing something for a condition they don't yet think they have. And in fact, what I found is I get more interest in lifestyle change from younger people to promote their performance, to help them be more fit, or to have a sharper brain, or to whatever it might be, or better memory. Of course, well, I guess that actually appeals to us old people as well, have a better memory. But if I remember right. But it is changing. It is changing. But you're so right. The ideal thing is to start in the womb, right? From what we've just learned. Start in the grandmother. Yes, back there.
I have diabetes, and I tried vegan diet. I was just eating salads, nuts, healthy. I didn't per se exercise, and I did it for 4 or 6 months or whatever. I also had high blood pressure. It didn't seem to really reverse my diabetes. I don't know if I'm missing something. And then one day, all of a sudden, I was feeling really, really bad. And I suspected my blood pressure might have dropped. That's never ever happened. And I rushed home in a panic, and sure enough, that's what happened. And then I didn't know how to bring it back up. And then I just gave up the diet altogether and said, forget it. And I went back to eating a bunch of garbage, and I've been doing it since. And I know it's ruining my health. And I don't know if I was missing something to reverse it or what, but I'm just type 2.
Yes.
I'm metformin and a few
So-
other things.
Yeah, so let me summarize it real quick for the this recorded on it. So, the gentleman is asking about, or telling about an experience of being type 2 diabetic, adopted some healthier eating for some time, didn't seem to see much difference, then had an episode where his blood pressure seemed to drop rather suddenly, and didn't know how to handle that, and just went back to the old ways, more or less, and but is aware that the evidence indicates this is not good for his long-term health. What can he do about it? Well, let me just tell you that one of the reasons that I became a specialist in intensive treatment is because there are lots of ideas on the internet and various places, even in doctors' offices, that don't actually, they don't work. So we need, and when we started the American College of Lifestyle Medicine 20 years ago, one of the main reasons is we wanted to eliminate the non-evidence-based ideas about lifestyle change. Because, you know, if you pick any trade you want, suppose you're a mason, for example, and there are people that are selling mortar mix that's full of sand and dirt, okay? Well, it's not you doing it, but it's giving a bad rep to your trade, because people are putting up these walls or whatever they might be, and they crumble and so on. Okay, so the American College of Lifestyle Medicine, one of the key things it's done is to promote evidence-based lifestyle changes. And so I became a specialist because I believe that we needed to see the power. See, in my opinion, what I would love to see happen for you, sir, would be to get in an intensive program conducted properly that can change the gene switches and see what can happen even in a short time, like we're just now finishing up, is it tomorrow? The day after tomorrow, we graduate. And we're going to see the results from blood testing. We already see people who are feeling better, looking better, and coming off of medications. And I teach doctors lifestyle medicine. And I can tell you, with almost uniformly, one of the things they say is, Dr. John, I knew that lifestyle, it was good. I had no idea that it was this good, and it helps everybody. Now, not everybody gets off their medication in 10 days, but everybody has improvement in some things. So I would encourage you to look into some truly credible lifestyle intervention programs and see if you don't find out that there is actually a solution. That would be my encouragement.